Hello everyone. I'm going to talk a little bit about regular polygons, and then I'm going to do just one example using our formula for the sum of the interior angles. So first, I want to talk about the definition for regular polygon. So we already know the definitions for equilateral and equiangular. So equilateral this means that all the sides are congruent. So for example, an equilateral triangle or maybe a square. Okay? And similar, equiangular, this means that all the angles are the same. So again, in an equilateral triangle, we know that all the angles are equal to 60 degrees, so all the angles are the same. That's the definition for equiangular. So when a polygon is equilateral and equiangular, we call that regular. So a regular polygon is a polygon that is both equilateral and equiangular. So for example, an equilateral triangle or a square, or if you think about an octagon, like a stop sign, that would be a regular octagon. Okay. So when we know that a polygon is regular, that already gives us a lot of information. We already know that all the sides have to be congruent. We know that all the angles have to be congruent. And then what that means is we can actually go one step further with our formula for the sum of the interior angles of a polygon. So, just a reminder here, the sum of the interior angles was equal to n minus 2 times 180. So the n minus 2, remember that represents the number of triangles we can split it up into. Each one of those triangles has 180 degrees. Well now, if I know that all the angles are the same, so if I have a regular polygon, I can take this and I can figure out how big each angle is in that regular polygon. So if n represents the number of sides, n also represents the number of angles. So if n minus 2 times 180 gives me the total sum for all of the angles in that polygon, if I take that sum, divide it by how many angles we have, that gives me the measure of each angle. So for example, let's think about a regular 15gon. So this is a polygon with 15 sides. We know it's regular, so we know all the angles are the same. So if I want to figure out how big each angle is, n minus 2 times 180, that will give us the sum. We'll divide that sum by the number of angles we have. So we have 15 minus 2 times 180, and then we'll divide that by 15 again. So doing a little bit of simplifying, 13, that's the number of triangles we can split it up into. Each one of those has 180. We'll divide that by 15. So in the numerator, 13 times 180, 2,340. And that, then dividing that by 15, we end up with each angle is 156 degrees. So taking our formula for the sum of the interior angles, n minus 2 times 180, if we know that the polygon is regular, all we have to do is divide that by the number of angles we have, and we can get the measure of each angle.